Video 6, Extending the Rules of Indices and Surd Manipulation. Part 1, Extending the Rules of Indices. We saw these back in video 4. There they are again. And to remind you how they worked, if you had x to the power 4 divided by x to the minus 3, that's the second rule, so you take them away. 4 minus 3 is x to the power 7. X to the half times x to the 3 over 2, the first rule, add them together, a half plus 3 over 2 is 4 over 2. You would not, however, leave it like that, but you would cancel it down to be x squared. X to the 3 to the power 2/3, the third rule, so it's 3 times 2/3, 6 over 3, x squared, simplified again. 2x to the 1.5 divided by 4x to the minus 0.25, big numbers first, 2 divided by 4 is 0.5 or a half, little numbers next, x to the 1.5 divided by x to the minus 0.25, that's a taken away, so it's 1.5 minus 0.25, or 0.5 x to the 1.75, or alternatively you could write it as a half x to the 7 over 4. Fractions tend to look nicer than decimals, so where possible try to make the answer look nice. A half x to the 7 over 4. 9 to the power a half. Whenever you see a half in an index, you instantly think the square root. The square root of 9 is 3. 64 to the power a third. When you see a third in an index, you instantly should think cube root. The cube root of 64 is 4. 49 to the 3 over 2. Split it up into the two separate parts. The half means the square root, so it's the square root of 49, and the 3 part means cubed. 7 cubed, 343. 25 to the minus 3 over 2. Think about what all the individual bits mean. The minus means 1 over. The 2 in the denominator means square root, and the 3 in the numerator means cubed. So it's 1 over 25 to the 3 over 2, 1 over the square root of 25 cubed, which is 1 over 125. In an exam, write down the steps between the question and the answer. Do not try to do the working out in your head and just write the answer down, but write down all of the steps to make it clear what you are doing and to minimize the chance of you making a mistake. 2/3 to the minus 1. Minus 1 basically means the reciprocal. The reciprocal of 2/3 is 1 over 2/3, and 1 over 2/3 we can write as 3 over 2. 1/8 to the third. A third means the cube root, so it's the cube root of an eighth, or the cube root of 1 over the cube root of 8, which is a half. Part 2, Surd Manipulation. We use surds to represent exact values. Quite often an exam question will say give your answer as an exact value, in which case a surd may well be a part of the answer. Surds are essentially square root signs or other signs like that, so the square root of AB is the square root of A times the square root of B. The square root of A over B is the square root of A over the square root of B. So if we had the square root of 12, that's the same as the square root of 4 times the square root of 3. The square root of 4 we can calculate, which is 2, so it's 2 root 3. we try to make the number inside the square root sign as small as possible. That's when we have simplified it. So root 20 over 2. 20 is root 4 times root 5, because 4 5s are 20. So it's 2 times root 5 over 2, and then the 2's cancel and you're left with just square root of 5. 5 root 6 minus 2 root 24 plus root 294. If we simplify them, we can call it a common surd. So 5 root 6, 24 is 4 6's, so that's root 4 root 6, and 294 is 49 6's, so that's root 49 root 6. 5 root 6, can't do a lot to that. The square root of 4 is 2, so it's 2 times 2, that's 4 root 6. The square root of 49 is 7, so that's 7 root 6. 5 root 6's take away 4 root 6's, add 7 root 6's, means you've got in total 8 root 6's. So we simplified it. We found a common surd, root 6. We've made sure that's the smallest surd we can possibly get, and then we've combined like terms. In this case the like terms are in terms of root 6 to get 8 root 6. Part 3. Rationalizing a denominator. Rationalizing is a process where a surd is moved from the bottom of a fraction to the top. So a over root b, if we multiply the top and the bottom by root b, that becomes a root b over b. So now there's no surd in the bottom. A over b plus root c, in order to rationalize the denominator, we multiply the top and the bottom by b minus root c. Think back to the difference of two squares you saw in video 5 as to why you'd want to do this. A over b minus root c, to rationalize it we times by b plus root c in the numerator and the denominator. So, if we want to rationalise 1 over root 3, this is using the first rule, we would times it by root 3 over root 3. That's essentially timesing it by 1. So we haven't changed anything, because timesing by 1 doesn't alter a sum. However, we have now made it so that it's root 3 over root 9, or root 3 over 3. The bottom, the denominator, is now a rational number. It's neater and it's nicer to have the denominator as a rational number. 1 over 3 plus root 2. The second rule means we times it by 3 minus root 2 over 3 minus root 2. So the numerator becomes just 3 minus root 2. The denominator becomes 3 plus root 2 over 3 minus root 2, which is just 7. We can also use the idea of difference of 2 squared, so it's 3 squared minus root 2 squared, so 9 minus 2, 7, to work out the denominator in that case. Root 5 plus root 2 over root 5 minus root 2, it doesn't look very nice because we've got surds in the denominator, so if we rationalise it, we times by, using the third rule this time, root 5 plus root 2. On the top we have root 5 plus root 2 times root 5 plus root 2, so when we times the numerator out we end up with 5 plus root 5 root 2, which is root 10, plus root 2 root 5, which is root 10, plus root 2 times root 2, which is 2. So that's 7 plus 2 root 10 on the top. On the bottom we can use the idea of the difference of two squares again to say it's root 5 times root 5, which is 5, take away root 2 times root 2, which is 2, to leave us with 3. So it's 7 plus 2 root 10 over 3. Occasionally, an exam question might say write this in the form a plus b root 10, in which case you would have to give the answer 7 over 3 plus 2/3 root 10.